This is Kaylan, better known as Professor Cygnus and Angels. And my angels and I are as one human being. I know it is beyond the sight you are seeing. We're doing very good, my miracles, my wonderful angels. I'm the founder of the nonprofit Cygnus Industries, and I am an inspiration for people to live as non-sinners regardless of trauma and injuries. Hey, if you have the opportunity, make sure to have your fanny pack at all times. And remember, if you do not have a fanny pack or do not have access, on our YouTube channel, we as my angels and I as one human being and the metaverse and you all, there is an episode on the YouTube channel of how to make a vine fanny pack for free. All you have to do is collect vines, and that is the only tool that you will need besides your two hands. And the step-by-step process is on the YouTube video. Always have your fanny pack, and you can carry your hygienics in that no matter where you go, whether if you're at the house, office, store, outside, etc. You could have everything you need right when you need that. Let's go ahead and get our chapstick on. Very good. Today we will be speaking about the importance of numbers. Numbers have been around for thousands of years, yet the current numbers that they have in today's time is a different organization than what they had many years ago. The development of numbers had developed over time and had become in law for the numbers. Did you know, in order to register a number type, you would have to go through legal statuses? In an example, a quintillion is a legal number because that had been certified, but a zillion is not a legal number because that number has not been certified. I know you've possibly not ever heard of a quintillion or a zillion, and there are lots of debates about numbers. Yet it is important to understand that there are legal statuses about numbers. Without numbers, we would not be able to have measurements for buildings. Without numbers, we would not be able to have an algorithm of digital codes. Without numbers, we would not be able to measure anything, we would not be able to build anything, and we would not be able to do so many things without numbers. We should be thankful for numbers. On the number chart, we have the numbers 0 through 9. Can you count to 9 with us? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Very good. Let's try that one more time. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you say, why did you not add 10? You see, real numbers are just 0 through 9. And then we have something called the numbers place. There is tens, then there's ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, and billions. We will go over the ones. 1 is one single object. 0 is none. And 1 is one single object. In an example, there is one container of salt. But how many salt grains are in the container? Looks like we would have to calculate from the chart of the numbers place. Very good. So first we have ones, then tens. If you put up all of your fingers, you will find 10 fingers, and plus your thumb, which is not necessarily counted as a finger, yet we will count that in this session. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have hundreds. And you see, all of this goes from 0 to 9, and then the next digit changes. We'll start from here. So then once this goes to 9, then the tens digit changes to 1. And then the tens digit depends upon the ones place. The tens digit and the hundreds place depends upon the tens digit. The thousands place depends upon the hundreds digit. And they all depend upon each other. After 1 billion, we would get tens billions, 100 billions, and then trillions, then 10 trillions, then 100 trillions, and then a quadrillion. After quadrillion would be 10 quadrillion and 100 quadrillion, and then a quintillion. Wow, there's so many places for numbers. But remember, numbers have to be legally certified. So anywhere past a quintillion, you would have to make sure to study and do research to make sure that the number is legally certified. Very good. Numbers have helped people with so many things in life. Whether if it is accurately measuring the measurements of things to be able to build things, make things, create things. Whether if that is to do mathematical equations. And then you say, what is mathematical equations? Very good question. Mathematical equations helps us to understand life in a better way. In an example, if we had 1 can of salt, 1 container of salt, and we wanted to add a Glade spray can, then we would say 1 container of salt plus an additions to a container of Glade spray. So we just did addition there. And there's 2 containers of different things. Because 1 plus 1 equals 2. Very good. Then you would have 2 containers. And now we will go over the importance of addition. Very good. So we know that 1 plus 1 equals 2. And 2 plus 2 equals, we'll count, 1, 2, 3, and 4. That is 4. So then we will do 3 plus 3. So put 3 fingers on one hand and 3 fingers on the other hand. Now count from right to left, or from left to right, since we read from left to right. 1, 2, 3, 4, 5, 6. That is 6. Very good. So thus for 3 plus 3 equals 6. Very good. Then we have 4 plus 4. So then you would put 4 fingers up on this hand and 4 fingers up on the other hand. And how much does that add up to? Let's count together. 1, 2, 3, 4, 5, 6, 7, 8. 8 fingers. Very good. So that means that 4 plus 4 equals 8. Very good. And now we will do 5 plus 5. First we hold up the first hand, since we know that we have 5 fingers. And then we will hold up the other hand with all of the fingers up. Now we will count all of the fingers together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So that means 5 plus 5 equals 10. Very good. And now we will do subtraction. Subtraction is the opposing from addition. Addition is when you add. Subtraction is when you subtract. Thus for minus. Or plus is the opposing from minus. So if we do 1 minus 1, that means that we will have none. Because we are not adding, we are subtracting. So that means we are taking away. So 1 minus 1 is 0. Very good. Now we will do 2 minus 1. So here is 2 fingers up, so we'll take one of them off. So then there's 1 left. That means 2 subtracted by 1 is 1. Very good. Now we have 6 subtracted by 3. So 6 minus 3. So that means 1, 2, 3 fingers need to go down. And then we will have the other remaining. So let's count how much is remaining. 1, 2, 3. 3 fingers are left over. So that means 6 minus 3 is 3. Very good. Now we will do 4 subtracted by 2. 4 subtracted by 2, so let's take 2 away. That means there is 2 remaining. Very good. Now we will do 5 minus 1. So we have 5 fingers up. Now we'll take that finger off of there, and we have 4 remaining. So that means that 5 minus 1 equals 4. Very good. Now multiplication. Multiplication is when we add the same number of how many times that is requesting. In an example, let's do multiplication from 1 times 1. So that means we have to add that how many times they ask. So if 1 plus 1 equals 1. So let's try 1 multiplied by 2. So that means we have to add 1 twice. So 1 plus 1 equals 2. Very good. Now we will do 2 multiplied by 3. That means that they're asking us to add 2 3 times. Or we could switch that around and add 3 twice. Because 3 times 2 is the same thing as 2 times 3. So let's try to add 3 2 times. Come on. 3 plus 3 is 6. Very good. So that means that 3 times 2 and 2 times 3 is the same answer of 6. Because if we add 2 3 times, that means 2, that's 1, 2, 3. So let's count up how much that is. 1, 2, 3, 4, 5, 6. That means that 2 times 3 is 6. The same way of 6 times 3. Or not 6 times 3, 3 times 2. Do not interrupt. Now we will do 4 times 4. Remember, this is not addition. This is multiplication, meaning that we would have to add 4 4 times. 4 times 4. So that means we would go 4, 5, 6, 7, 8. That's 4. So add 8. So 4 multiplied by 2 is 8. So then we would continue. So add 4 fingers every time. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Aha! 16. We put 4 fingers up. That means 4 multiplied by 4 is 16. Very good. Now we will do 5 times 5. So first we need to hold up all 5 fingers by the time we are done, but we need to add 5 until all these fingers are up. So we will use these fingers to add 5 every time. And once this has 5, we're going to lift 1 finger up. 5. So add that up. So 5 times 1 is 5. 6, 7, 8, 9, 10. 5 times 2 is 10. 11, 12, 13, 14, 15. 15. So 5 times 3 is 15. 16, 17, 18, 19, 20. 20. 5 times 4 is 20. 21, 22, 23, 24, 25. 25. Looks like the answer of 5 times 5 is 25. Very good. Now you understand multiplication. Now we can go into division. Division is when you see how many times that a number goes into another number. Let's give some examples. 1 divided by 1 is 1. Why? Because 1 goes into 1 that many times. That means how many times can you get that number out of the number that they are asking? And another example. 2 divided by 3. So let's hold 3 of our fingers up. How many times does the number 2 go into the number 3? Well, how many fingers do you got? You got 3, so that means 2 goes into that one time. Oh no, there's a finger that's left over. That means there is a remainder of 1. So that means the answer to 2 divided by 3 is that goes into that one time, but there's a remainder of 1. Very good. So 2 divided by 3 is 1 with a remainder of 1, because 2 only goes into 3 one time. Very good. Now we will do 4 divided by 5. So let's hold 5 fingers up, because that's the bigger number, or that's the number that goes after the first number. So we want to know how many times does the number 4 go into the number 5. So we will hold 5 fingers up, and then we will know what is 4. Here is 4, the 4 fingers. Oh no, there's 1 remaining. If there's 1 remaining, that means that this only goes into this number 1 time. And then there is a remainder of 1. Very good. So now we will do 3 divided by 9. So if we do 3 divided by 9, let's hold 9 fingers up. Very good. So how many times does the number 3 go into the number 9? Let's pair this up. So here is 3 pairs here. 3 fingers go into a pair. We'll put that together. Look at this. Now we have 3 pairs. That means that if we pair that up 3 times, that means that goes into that number 3 times. Because the number 9, 3 goes into the number 9 3 times. Very good. So thus for 3 divided by 9 equals 3. Very good. Now let's go into the next equation. 5 divided by 10. So let's hold up 10 fingers. So 5 divided by 10. That means that how many times does 5 go into the number 10? Let's see. How many times can you get the number 5 out of the number 10? 5 fingers here and 5 fingers here. It looks like only twice. Only 2 times. So that means that 5 divided by 10 equals 2. Very good. Now we will go into prime factorization. The prime factorization of 54 is 2 times 3 times 3 times 3. Whoa! Let's take this one step at a time. In order to find prime factorization, you want to see how many times that you can go into that number. Let's write down some examples. When you do prime factorization, you want to make sure to break this down like a tree. Do you see this tree? The number that you are trying to find the prime factorization of will go at the very top. Let's write this down. And then you could try to write that down in your mind. If we are trying to find the prime factorization of 54, then what we will do is we will first divide the number 54 in half. We want to know what is half of 54. So let's divide. Very good. When you divide a larger number, only do one digit at a time. So here you will see 2 with the roof over. The bigger number goes under the roof, while the smaller number goes outside of the roof. Very good. So thus, we need to know how many times does 2 go into 5. We will start with the smaller numbers. So 2, 4. So 4 is the answer, but that only goes into that number how many times? 2, 4, twice. So we will put the number 2 at the top, where the answer goes. And then the number that we got will go underneath the number 5. And then we will subtract 5 from 4. And what number do we get when we subtract 5 from 4? 1. Very good. And now what we will do is we will carry this 4 down. We are left with the number 14. So now we need to know how many times does 14 go into the number 2. Let's add this on our fingers. So 2, 4, 6, 8, 10, 12, 14. 7 times. So that means that we will write the number 7 onto the top. And then the number that we got, which was 14, will be written underneath that, and we will subtract the numbers. Looks like 14 minus 14 is 0. So that means there are no remainders. So that means that 2 multiplied by 27 is 54. We can make sure of this by multiplying these numbers. 2, when we do multiplication, we want to multiply from right to left. So we will start with the number 7. 2 multiplied by 7 is, we could do 2 plus 2 plus 2 plus 2 until we get to 7 times, or we could add 7 plus 7. So that means we could do 5s first. 5 plus 5 is 10. But now we have to add the 2 2s. 11, 12, 13, 14. So we will put the 4 down, but then we will carry the 1. Now we will add 2. Now we will multiply 2 from 2. 2, 4. Plus the 1, 5. So now we can see that 2 multiplied by 27 is 54. Very good. Thus for, the division had told us what number we needed to multiply. If we wanted to find a prime factorization of the number 54, we divided to know. So now we will branch off our tree. So now we have the numbers 2 and 27. We know that the number 2 is a prime number. So we will carry down the number 2. But now we will see if we can break down the number 27. Let's see if we can divide 27 into 3, since that is an odd number. So 3 divided by 27. We will divide 3 by 27, starting with a 2. 3 does not go into 2, so now we have to do 27. So 3, 6, 9, 12, 15, 18, 21, 27. 9 times. And here is a neat trick that you could do on your 9's multiplications. What you will do is you will put your hands out in front of you. If you wanted to multiply 9 times 3, you will do this here. You'll put your hands out facing your face. Then you will count 1 from left to right. 1, 2, 3. The third finger will go down. You have 2 on this side and 7 on this side. That means 9 times 3 is 27. Now we will put any finger down. The fourth finger. So we have 3 on this side, 6 on this side. That means 9 times 4 is 36. So let's try to put the fifth one. Now, 9 times 5 is, we put the fifth finger down, 45. And we can do that on all of our fingers to know the correct answer. Very good. Let's make sure of this, that 9 times 3 is 27. Looks like we did that. We did division. Very good. So now we know that 3 times 9 equals 37. So we are going to draw that on the tree chart to get the prime factor of the number 54. And this is called prime factorization. So we know that 2 is a prime number. So we will keep carrying that number down. Very good. We know that 3 is now a prime number. But look at this. We could break down the number 9. How so? Try adding 3, 6, 9. So 3 multiplied by, so we have 3 on this hand. Bravery, do not interrupt. We have 3 fingers on this hand, 3 fingers on that side, and 3 fingers on this side. 3, 6, 9. So that means 3. Three multiplied by 3 is 9. That means that we just broke this down another time. Very good. So now we know that the prime factorization of 54 is 2 times 3 times 3 times 3. But since we have so many 3's here, we could write a tiny little number here that represents how many 3's that we have. And an example, if we put the number 3 here, we could write how many times that we have the number 3, which is 3 times. Very good. So the prime factorization of 54 is 2 times 3 3 times. Very good. There's so many reasons why we really need to understand mathematical equations. We utilize math in our everyday life, whether if you know that or not. When you have an object in front of you, have you ever just tried to calculate how far the object was from you? Well, guess what? Your brain does that for you. Your brain practically calculates how far an object is so that you know how to grab that and where to grab that. If you calculate the measurements of the object, perhaps you could move that and then calculate how light or how much pressure that you have to utilize to grab the object firmly like this, or to grab the object in a light pressured way. Very good. Everything takes proper measurement of calculations, and without numbers we would not be able to do anything. Numbers are very important. Numbers are in fact the way of our life, and you should be very thankful for numbers. Let's count from 0 through 9 one more time. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. One more time. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Excellent processings. Very good. And always remember the number places. We have ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, then billions, then 10 billions, then 100 billions, then trillions, then 10 trillions, then 100 trillions, then quadrillions, then 10 quadrillions, then 100 quadrillions, then quintillions, then 10 quintillions, then 100 quintillions. And you see, the ones place depends upon the tens place. The tens place depends upon the one place. The hundreds place depends upon the tens place. And once that number goes to 9, then the other digit changes in the other place. That's all that is. Very good. And there is so much to numbers. Sometimes people come up with number codes or even representations of what numbers mean. But numbers are important for our daily life, and you should be very thankful for numbers. Praying that you all learned mathematical things today. Stay healthy, stay clean, and stay safe. And remember that the nonprofit Cygnus Industries looks forward to create a farmers market, animal sanctuary, manufacture the books for the blind, help robotics become more involved, and so much more. You can support the Cygnus Industries for the great